Hello. Oh, hello everyone. Okay, so today we are going to learn something very interesting, okay, which nobody will teach you, which no teachers or will teach you because this is more into practicality. All right. So I have a slide in front of me which says I am 13.228.199.255, or you can call me IEEE CS Computer Society. So what does this mean? I'm saying that the name IEEE CS Computer Society corresponds to 13.228.199.255. Now, in the internet, or how devices communicate between each other, how it works is not with the names. I am Darshan, but to my computer, to my phone, I am not Darshan. Okay. I am assigned to the number called an IP address. Okay. That is this number. Okay. This is an IP address. What kind of IP address is this? I will get back to it soon. But the internet does not know that IEEE Computer Society's website is called IEEECSVIT.com. No, it does not know it that way. It only knows that it is called 13, 228, 199, 255 with three dots separated with four numbers. All right, let's go to the next slide, which says a watch. Okay. Now, what does this have to do with what we are studying today? Right. Now, every device which has to communicate between each other, every electronic device which has to communicate between each other is assigned with an address, which is called an IP address, which I just told a minute back. Right. Now, a watch has an IP address. Next, a TV, a smart TV has an IP address, right? All these services you're using in a smart TV, which is Amazon Prime, Netflix, Apple TV, YouTube, everything needs communication. And if communication is there, you need IP address. Is that understood? Now, obviously, a phone is a very basic thing, and that gets you connected to the internet. Correct. Now, let's say you have two cases here. One case is that you're using your 5G cellular data, and the other case is that you're using your home Wi-Fi or your office Wi-Fi or your cafeteria Wi-Fi. Okay, there's a slight difference between both these. Okay, so how this works? Who gives these IP addresses to us or to my phone? Who gives these addresses? It's your default gateway. Who's in default gateway? You will be surprised to know who that is. It is your router. It's your default router. Okay, it's your home router. You must have seen your home router, right? It's probably which goes with a company name called Linksys, Cisco, or one of these. Okay, these are very popular ISP providers. I mean, these are not the ISP providers, but yeah. What I mean to say is, if you are using 5G, that is your mobile cellular network to connect to the internet, the IP address is not given by the router because clearly you're not connected to your home Wi-Fi. Okay, in that case, who gives the IP address? Your internet service provider, which is called, or otherwise we can say it as ISP, right? Internet service providers, you know what they are: Geo, Airtel, and yeah, those are ISPs. Now, this obviously can identify this device, which is a router. It looks like a gaming router. Different routers have different powers. Your different routers have different powers. They have different bandwidth to communicate with. So yeah, more the antennas, more the connectivity. There's no direct relation to that, but yeah, usually gaming routers are really powerful because gamers need less ping. What is ping? We will come back to that. Now, before going to any other command, let's see what is NSLOOKUP command. Okay. In the first slide, I had mentioned this one, correct? 13, 228, 110, 199, 255. Okay. And I have this slide also with me. Okay. I'm team Vimanas.xyz. I'm called something else in the underworld. Now, I just told you that this website, IEEE CS computer website, has this IP address. This is how the internet understands this. Now, similar way, even this website is understood in a similar way. Okay, as such a number is given to this website. Okay, now let's go to IEEE CS Computer Society's website. All right, let's just open new tab. IEEE CS VIT. Let's just type, and here pops up my website. Right, and now this is a domain. I'll come to what a domain is quickly, but this is what you do, right, to reach this website. Now I have copied this command. I mean, I've copied this link, domain. Okay, and one sec. Let me just go to my. Wait, just a minute. Yeah, yeah. I'm hoping that my terminal window is visible. All right. Yeah. Now I'm typing the command nslookup. Okay, I'm pasting this. Okay, and this is the entire link, but we just need the domain, that is ieeecsvit.com. Okay, now what happens when I press an enter button on the keyboard? Oh, you can see some output, right? Now what does this mean? Address 13 251 986 10, 13 215 144 61. There are two addresses for this website. There are two addresses for this domain. Yeah, they can have two different IPs. This is because of a factor called load balancing, which is a higher concept which we do not need to discuss right now. Okay, but yes. Okay, uh, let's do ns lookup for more websites, or let's just do ns lookup for the the teamvimanas.xyz website I told you. Ns lookup teamvimanas.xyz. Okay, now similar out should come. Yes, now this time it has four addresses. Okay, now let's do something very popular. Okay, ns lookup. Let's do it for our vit's website. Okay, vit's domain vit.ac.in. Now when I press this, I should get a valid output. Now 136 233 913. Now you might have a question, or if you do not have this question, please think about this. I said that the internet refers to the website in this way, okay, and not this way. So instead of typing vit.ac.in, can I type 136.233.9.13? Will that work? Will that load my website? Let's try it out. But according to logic, it should work, right? I'm pasting it here. Yeah, it has loaded clearly, right? Now you cannot see vit.ac.in here. You can see the IP here. Okay, this is how domains and websites or anything are referred on the internet. Okay, it's for our simplicity that there's something called DNS is given. Okay, DNS. Okay, DNS stands for domain name system. Okay, DNS. DNS lets users connect to websites using domain names instead of IP addresses. Okay, if you were to remember such a big number, okay, like with four different numbers in it, okay, that's going to be hard. Can I access vt.ac.in with some random four-digit number? It's clearly easy for me to refer it as vt.ac.in or google.com or vtop.ac.in, vit.ac.in. Correct. So that is why DNS is here. Okay, but there's something called DHCP. Okay, why do we have DHCP? Is something advanced again, but the number you just saw is not going to be permanent. Okay, it's not permanent. Most of the time it's not permanent, and when it's not permanent, we call that as a dynamic IP address. Okay, every time or every now and then the IP address given to a particular domain is changing. Okay, so vat.ac.in does not necessarily need to be this number. Okay, it could change. It could change something like 7.14. No one knows. Okay, it's how the protocol works. And if at all the IP address stays constant throughout lifetime, okay, that is called a static IP address. Okay, is that understood? Okay, now let's go back to the slide. Now we have looked at what NS lookup is. Okay, let's go to the next command, which is ping. Okay, now what is ping? Gamers are well aware about this term, but do you really know what this is? Okay, lesser the ping is better the gaming is what I've heard from gamers. But let's get this clear. Okay, it is that way, but let's see it in reality. Okay, let's see how it works in reality. Now, ping is used to check whether if I am sending a message to the website or if I'm sending a message to the address, okay, if I'm sending a message to something on the internet, okay, it's going to respond back if it is up and running. Okay, if it is up and running, it's going to respond back. Correct? Now, the response time, okay, is going to be displayed by ping. Okay, so the higher time, the more the time it takes for the website or the domain to respond back to me, it's worse, right? So if a person is shooting, okay, in a game, okay, and let's say he has already shot the bullet, but the server took so long to respond back that the opponent shot him back, okay, before he shoots the opponent. Okay, you get that? So often you see gamers getting frustrated why, oh my god, ping is so high, what's wrong with me, what's wrong with my computer, what's wrong with my network. Okay, it is this what they're referring to. Let's just see. Let's just ping google.com for example. Instead of that, okay, let's just try google.com. And yes, now let's stop it. So it has pinged several number of times. Okay, if I do not specify a parameter here, it will ping until forever. Okay, now 64 bytes are sent. Okay, now the response time, the time it takes for the server to respond back is 25.24 milliseconds. Okay, this is the response time. Okay, so clearly higher the number this is, okay, it's bad for us. Okay, and let's say we are running google.com, let's say we are running something, okay, and our clients are finding it really hard to reach out to us. Okay, this is one issue we are supposed to solve. Okay, the second issue is if we are the clients, like I'm the client here, okay, to google.com, I'm supposed to make sure, let's say I'm doing some very important task like booking something online, okay, which is running out of tickets or something like that. Okay, if my server is taking a lot of time to respond back, okay, that's bad. I'm supposed to be responsible for that. Correct? Now you're going to get the blame for not getting that particular ticket, or this ticket is just for an example. I hope you understand. Yeah, so it says 6 packets are transmitted and 6 packets received. Okay, that means 6 packets you sent and 6 packets you received back. There's 0% packet loss. Is that understood? There's 0% packet loss. Now, uh, let me just show you guys something. Now, trace route. Okay, what is trace route? The term itself says that tracing the route, tracing the path. Okay, so let's say you have a client and a server. You're supposed to access that server, okay, for something. Okay, you're requesting a website, you're requesting something from the web this thing, okay, from that particular address. Now This path it takes, right? This path from you to the server is not a single road, okay? It takes of multiple signals and paths, okay? It stops at multiple places and it gets redirected at a multiple places, okay? So let's see how to use this traceroute command, okay? So before going to the traceroute command, I would like to show you something really cool, okay? uh just a second. Yep. Yes. Yeah, I hope this is visible. This is the cable map of the world, okay? How these cables are underlying the ocean, okay? And this is actually how we can communicate, okay, between different countries, okay? It's not entirely wireless. If you think it's that way, it's not like that, okay? And this is how it is. You can click any cable and see the specifications, okay? Now, clearly, it takes a lot of parts. It's not a single wire going through the world. Make sense? Okay. Yeah. Let me just go back. Mm, okay. I have config command. This is my virtual machine. All right. So virtual machines are nothing but you can run different operating systems on one operating system. Okay, my primary operating system, my host operating system is Mac OS. Okay, but I'm running Linux distro on this. Okay, this is possible only because of a hypervisor. Hypervisor makes it possible for you to run different operating systems on a single host operating system. Is that understood? So technically, instead of using another computer, I'm using another computer in my own computer. Okay, like in a single computer, I'm creating another operating system such that I can share the host operating system's resources with the new operating system's resources. Okay, so this operating system which you're seeing is not macOS, and this is using the hardware components of my MacBook itself. It's not some other hardware, or it's not some other computer. It's the same computer is using the same hardware. Now here, let's type a Unix command, which goes by the name ifconfig. Oh my God, there's a lot of output here. We do not understand what's going on. There's local loopback, there's inet something, 127.0.0.1. The hell is this? There's again some different inet. There's something called ether with colon. Okay, it's not dot now, it's colon. What's all this? Right. Now, if you're a Windows user, you go to command prompt, okay? You type uh, command cmd, you search cmd, or you can type Windows, okay, plus R. Okay, if you press this, it opens the run window, okay? And once you are done opening the run window, you can type cmd and that will open the command prompt. Or simple, what you can do is you can just open the search bar, okay, and type cmd and press enter. Or even a Windows PowerShell would work. Okay, I recommend using a terminal or a shell which has Unix-based commands. Okay, because Unix-based commands are more diverse and they're often used in servers. Okay, so yeah, you can use git bash. You can install it and you can run the exact same commands I'm typing here on Windows. All right, cool. Now we have seen a lot of output here. Now let's try to understand what this is. Okay, broadcast, inet, okay, and then this inet, and then net mask. Okay, okay, okay. I did not understand anything. Is if that's your thought process right now, I'm gonna fix that. Okay. Now I told you when you get connected to the internet, okay, you connect to your Wi-Fi router, right? Now your Wi-Fi router supplies IP addresses to your devices, your phone, your MacBook, your TV, your laptop, your mother's phone, your mother's laptop, your dad's phone, your dad's Apple Watch, everything. Okay, let's say your fridge is connected to some kind of internet service. Okay, and it's a IoT, advanced fridge. It's a advanced refrigerator. Okay, and even the refrigerator will have an IP address, right? You get my point. Okay, now the home router assigns the IP address. Okay, now The home router assigns the IP address, but does this make the IP address limited? Can I like assign as many as IP addresses possible? No, there are a number of IP addresses only you can fix. Okay, and let's count how many they are. Okay, usually, usually my one second. Uh, let's check my IP. Let's check my IP. All right. I'm going to do that as IP config. And since my computer has a lot of other, you know, uh, connections like VMs, bridge networks, a lot of them. So you're going to see a totally different output. Okay. Okay. So this. Okay. So I'm saying this number is my computer's IP address. Okay. And this is what is given by my Wi-Fi router. Okay. Now my phone could have point 0.2, my laptop, my iPad could have point 0.9, my other computer could have point 0.11. Okay. Now if I ping these, they will work. They will work. Okay. This means I'm pinging to myself. I'm pinging to my own computer. Okay. This means I'm sending a message to my own computer, and this means what? My computer network services are up and running. Okay. Yeah. Now coming back to the topic where my IP addresses, which can be assigned by the default gateway or my router, which are exactly the same things, essentially the same things, are limited. Okay. The first address of the network in this case is 198.168.1.0. Okay. This is the address. Now this is called a network address. Okay. Net network address. Okay, this is called a network address, and this is the first address. Okay, and this cannot be used. You will not see any device assigned by this number. Okay, the next address is called the first usable address. Okay, the first usable address is taken by your default gateway itself. Your router is been assigned this address. The IP address of your router is itself 192.168.1.1, and this is called default gateway. Okay, and now there's one more address which you cannot assign. This is the last address. Okay, 192.168.1.255. Okay, and this is called the broadcast address. All right. Now, what is a broadcast address? I've showed you the broadcast addresses output in ifconfig command. Now, let's say you have to communicate with a bunch of computers, okay, in a network, and you need to send or communicate something with all the computers in that network. Okay, my phone, my computer, everything. You need to send something to everything that's present in that particular network. Okay, so will you send to each and every IP you find in that address in that particular network? Like let's say my phone is point 0.4, my laptop is point 0.5, my other computer is point 0.6. Okay, will you every single time communicate with point 0.4 first, point 0.5 first, point 0.56, point 0.6 after that? No, you would not do that way. The simple thing you can do is to communicate with this address, okay, which is called the broadcast address. Okay, if you communicate something with 192.168.1.255, which is the broadcast address of my network, okay, my local network. Okay, this is going to broadcast it to all the devices in that network. Okay, all the devices. Okay, if there are 100 devices present in that network, it's going to spread that information to all the devices. So there's something called subnetting. Okay, which is not going to be told by me in this particular session, because subnetting is rather, it's a work of pen and paper, and the whole point of subnetting is to split networks into different networks. Okay, like if you have a pool of IP addresses, you're assigning some particular pool to some particular owner. Okay, this particular bunch of IP addresses are for let's say sales department, okay, in a company. This bunch of IP addresses are for that department in that company. So you're splitting all these whole bunch of pool of networks into different sub networks, okay, and that is called subnetting, okay. And by the way, this is subnetted as slash 24, okay. Now if you actually learn subnetting and know what is the first address, that will be the network address. What is the first usable address, that will be the default gateway, okay. And next is the last address of that particular subnet will be broadcast address, and that necessarily not need to be 255, okay. All the numbers in this particular IP are between the range of 0 to 255. This number will be 0 to 255, 0 to 255, 0 to 255, 0 to 255. And that's how an IP4 address is formed. Okay. So not necessarily your last address ends with 255. Okay. Someone's last address could be ending with 14. Someone's last address could be ending with 75. Okay. Get my point? So for this particular slash 24 subnet, 255 is the last address. Am I clear? Yes. Okay. Let me go to the next. Yeah. Yeah, now I have just told you about IPv4 address. Okay, it's separated by three dots. Okay, and it has four numbers in it, ranging from 0 to 255 in each cell. Okay, but I showed you something with colon separation, right? And that is how an IPv6 address is represented. Let's just Google a simple IPv6 address. IPv6 address example. Okay, and yes, this is in the form of hexadecimal. Okay, now let's open IBM's definition. Okay, so it has the following format. Okay, with separated as colons. Okay, not periods. Okay, and it has 8 segments, whereas IPv4 has 4 segments. Okay, now this clearly states that IPv6 contains more number of addresses. You can host more number of computers or addresses in this. And why do we need IPv6 addresses when we have so many million addresses in IPv4 already? And that is something which happened because of a very abnormal phenomenon. Why? What is that phenomenon? We ran out of those addresses. We are out. We are already out of those addresses. And yes, those million addresses are over, and they're just over. Okay. It's close to like being done. Okay. So everyone in the community uh, tried to come up with a new solution, and they came up with the IPv6 address. And this is probably not going to run out of addresses anytime soon. Okay. And you can close your eyes and just follow using IPv6. Okay, this is not going to run out anytime soon. And yeah, this is all in form of this thing, hexadecimals. Okay, now this is a very interesting side. I want this to be understood very well. Okay, I showed something called a loopback address a while ago. Now, if you see this table, okay, if you see this table, if you see this table, okay, there are a bunch of IP addresses missing in this range. Okay, 127 is the IP address which is missing. Okay, 127.0.0.0 which is missing. Okay, that is the IP address which is missing. There's a whole pool of IP addresses which is missing. Okay, so where are these IP addresses? Where are these? Okay, and these IP addresses are called loopback addresses. Okay, so let's just see what loopback addresses are. I'll just show you loopback addresses. The IP address 2700.1 is called a loopback address. Packets sent to this address never reach the network but are looped through the network interface card only. Okay. Your computer, every computer which has internet, support, okay, will have something called NIC, Network Interface Card. Okay. NIC card. Okay. This will be present in your laptop and computer. Without this, you cannot communicate. Okay. Now, when you're pinging something like 127.0.1, you're basically sending packets to your own NIC. Okay. You are not communicating outside your computer. Testing. This is only for purpose of testing. Okay. And this is also called as localhost. All right. Now let's do some, hands-on testing with this IP. All right. Okay. Um, so let me just use the font. Okay. Let me ping 127.0.0.1. Okay. Oops. I'm sorry about that. Now clearly I can communicate with my own computer. Okay. And I told you that there are a lot of addresses missing. It's not just point one. Okay. Even if I ping point two, this is also a loopback address. Okay. And please go ahead and see why this is saying request timed out. Okay. But this is also on loopback address. Okay. Everything in that range is only for testing purpose. Okay. Now let's just log on to my Linux. And since my Mac and Linux are both Unix based systems, I can run Unix commands on both. Okay. Now, first of all, I would like to show you something practical. Okay. And I've talked about what 127.0.0.1 is. So IP ADDR shows just an alias command for no IF config. Okay. You can also use this. Okay. And we'll go to nmap soon. Now, before going to nmap, let's do something. Okay, let's play with our VIT website. Okay, let's block VIT website. Now I can see this, right? 136, 233, 9.13. Okay, it's still working. Awesome. Now let's come here. Now I'm going to go to navigate. I'm going to go to this file called hosts. Okay. So first I'll go to this directory called etc, and I'll open this file with a text editor called nano. You can also use vi or vim. Okay. Let me use vim. Okay, vim hosts. Since this file permission is only for administrators accounts, let me type sudo. Okay, sudo gives you permission to access this file as an administrator. Let me type the password, and I've opened this. Okay, now you can see something here which is commented. Okay, now initially this is how your host file will be. Okay, if you open this on Mac or Linux, this is how it's going to display. All right. And clearly, this is your loopback address, which is also called localhost. Right. Now, the IP address of VIT's website was what? Was what? This 136.233.9.13. Correct? We were able to reach this. And the domain name was what? The domain name was what? vit.ac.in. Now, if I assign this domain with the loopback address, okay, if I assign this domain with a loopback address, okay, and save and quit, okay, now let's see what's happening. Okay, uh, let's type vit.ac.in. Yes, it's not going to reach. Okay, it's not going to reach. Why? Because we have redirected vat.ac.in to our local host, which is our loopback. Okay. So when you access vat.ac.in, your computer cannot reach VIT's IP address. It will only reach 127.0.0.1. Okay. This is a simple way to block certain domains in your local network. Okay. And this is one of the ways which can, uh, enable colleges or certain agencies to block IPs. Okay, they use a different method, but this is one of the methods which can be used to, block. Now, moving forward to what is Nmap. Okay, if we're going to Nmap, I would like to discuss something called Apache. Okay, now Apache is a project. Okay, this project served almost I would say almost 100 of you know networking tools, not just networking tools, internet IT related tools. Okay, now services like Tomcat, Nmap are all by Apache. Okay, are all by Apache. If you know, if you are working on the IT field, you would definitely be using one of the Apache tools. Okay, and what is Nmap? Okay, Nmap is a network scanner. Okay, and okay, so does that mean I can scan what's in my network? Yes, definitely. You can scan what's in your network and see what all devices are connected to your no localhost. I mean, not localhost, your default gateway, your router. So let me just quit it. Before quitting, let me just remove this. Or instead of removing, I can just comment this out. Okay, this line will be ignored. Okay. So yeah, now if you search vt.ac.in on your browser, it's going to work. Cool. Now let me just run the nmap command. Okay. Yep. Okay. Now what is SN? Okay. Now essentially, nmap does port scanning as well. I'll come to what port is soon. Okay. This particular command will tell you how many hosts are up and running, and will also tell their particular IP address. Okay. So let me go with enter. So here it says there are two hosts up and running. Okay, it identified two hosts. Okay, now maybe after 5 minutes, if you run it again, okay, it's going to say four hosts. Okay, because there are four hosts and up and running in that particular network. Okay, so yeah, this is my IP address and this is the router's IP address. Okay, and this is Nmap's basic feature. Now SSH. Okay, now if you're going to SSH, I'll tell you what the definition of SSH is. It's a network communication protocol. Okay, so will I be able to connect to that particular computer? Yes, you will be able to communicate with that computer and you will be able to access everything in that computer if you have necessary permissions. All right. Okay, let's test this out. Okay, let's test this out. Okay. Now my virtual machine is of the IP what? It's of the IP 10, 211, 55, and 7. Okay. Now let me copy this. Okay. And go to my uh, Mac. Okay. And if I type SSH, IP address, and the username, okay, parallels in my case, and do this. Okay. And type yes here and type the password of that particular user account. Wait a second. Wait, no, clearly I've made a mistake. I don't think I've copied it well. Uh, Copy. I've copied the wrong address. So SSH parallels at, okay. Wait, what? Not sure why it's not copying from what, 10 211 55 7 10 10 211 55 7. Okay, it's saying port 22 connection refused. Okay, so that means there's something called, there's a concept of port. Okay, now let's just troubleshoot this. Systemctl status sshd, it's inactive. Okay, start sshd. Customer. Okay, it's up and running now. So yep, I'm logged onto my virtual machine. Okay, so using this SSH command or this SSH protocol, I can mention two things, which is the user account and the IP address of that particular computer. Okay, and by doing this and providing the password for it, okay, I can log on to this. Okay, but in this case, it did not prompt for a password because I've configured something more called exchanging SSH keys. Okay, that is not required as of now. So all you need to know is, to access a different computer, you need the SSH service or the SSH daemon, daemon, okay, running on both the computers. Okay, and by that method, you can mention the user at the rate the particular computer's IP, and you will be able to access this. Now, if I type who am I, I'm going to get parallels. Okay, if I type ifconfig, I'm not going to get 192.168.1.3. I'm going to get this 10 to 1155.7. 10 to 1155.7. All right. Okay. Let's go to the next topic, which is, oh, AWS it is. Okay. Now, AWS is a cloud service. It's a cloud provider. Okay. Okay. So what basically AWS is that it provides you with hardware to host your websites or any kind of applications needed. Okay, for IoT or any web development or any application development. Okay, you need to host it. You need a hardware. You need good amount of physical hardware support. Okay, you can go to AWS and ask for a computer which has a particular RAM. Okay, 8 GB RAM, 16 GB RAM, even 16 GB RAMs of computers. Yeah, with operating systems of Windows, Red Hat, Linux, Mac, even, right? So AWS provides us with virtual machines. Okay. Now, instead of just talking about AWS, let's log on to AWS. I have an account in AWS, and funny that I haven't paid my AWS bills yet. AWS. Okay. Let me just do this. Okay. So I have my, so this is MFA stands for multi-factor authentication. So when you set up AWS account, you will know what this is. So cool. So let me just go to AWS. Okay, this is a home page. Okay, now there's something called EC2. It's a service. Okay, I have a bunch of instances running there. Okay, so let's see my instances. Yep, I have two instances and one is running. Okay, which is actually running. Now I tick this. Okay, now slide this up. You can see two things. Okay, which is called public IPv4 address and a private IP address. Okay, a private address. Okay. Uh, Now let me actually connect to this. Okay, connect. Okay, and this is an Amazon Linux. Okay, Amazon Linux, but this is actually based on Red Hat Linux itself. Okay, so to see that, you can just go to, let's see, uh, release. Okay. Hmm. So this actually, you can see it's Amazon Linux, and it's based on Red Hat Enterprise Linux. Okay, so if you're using Amazon Linux, and if you're well versed with Red Hat Enterprise Linux administration, this is going to be a piece of cake for you. Now, this is my public IP. Okay, 172.31.2.106. Okay, here you can see, sorry, this is my private IP. I'm so sorry, this is my private IP. Okay, and just like how you saw 192.168.1.3 on my Mac, this is my private IP. Okay, now I won't be able to access this. Okay, I won't be able to access this outside my network. Someone else from, let's say, a different city or even outside my network, or, you get my point, right? They cannot access my device using this address. They can only access my device using this public IP. Okay, using this public IP. And remember, I've been telling you something called port, uh, PORT, for a long time. Port for a long time. Okay, now I have a service, I have a software called Jenkins. Okay, Jenkins running on my instance is basically an AWS server. Okay, and that runs on port 8080, port 8080. Okay, now if I catch this IP address and open a new tab, okay, and paste it here. Okay, paste it here, and I just told that it runs on 8080, port 8080. I enter, I'm into Jenkins. Okay, now I can just DevOps admin, DevOps admin, uh, sign in, and yep. Okay, so I've logged onto my Jenkins. Why and how? Simply because I know my public IP and I know my uh, port on which Jenkins runs. So this is a simple way to access services on your network. Okay, let's say you are testing something on VS Code. Okay, you're testing your basic uh, website. Okay, it's HTML website on VS Code, and there's a option where you can uh, there's an option where how do I say, there's an option where you can go live. Okay, that opens a web browser and shows the output of how your website looks like. Correct. So that runs on localhost. Okay, and the service is running is usually something like something from Apache or WSGI. Okay, like Django WSGI port. Okay, so the default port of uh, Django is 8000. Okay, if you are testing locally, it will run on 8000. So you will have to do something like localhost colon 8000 to see your local Django project. Okay, it's not visible to the internet. All right. So yeah, so there's a bunch of ports which are reserved in your computer. Okay, uh, I'll just note down and tell you what exactly they are. Okay, So so there are a lot of ports which are reserved, like 8080 is for Jenkins. Okay, you cannot touch that, and 8000 is for WSGI from uh, for Django. Okay, the reserved ports. Port is a 16-bit number, and total port is actually 65,000. Okay, and let's say HTTP service. Okay, HTTP service runs on the port 80. SQL runs on the port 1433. Okay, MongoDB is a database. Okay, if you are running MongoDB, it will run on the port 27017, 27,017. Okay, that's the port. Okay, for MongoDB. Okay, there are a lot of ports. There are reserved ports. Okay, okay. Now let's just see a bunch of reserved ports. Reserved ports. Popularity. Right. Now, did you see something called secure shell here? And few minutes back, it said port 22 is not accessible. Okay. Let's test this out. Okay. Let me go to my virtual machine. Okay. Let me just enter the password. Okay. And let me stop the daemon service of SSH. Stop. Okay. And for stopping, I need the password. Okay. Now, if I do status, it's inactive. All right. Now, if I come back to my computer and type SSH parallels at wait, I did not exit from this. I'm so sorry. Yep. Now, if I do this, it will say port 22 connection refused. Okay. Why? Why? You can clearly note here that secure shell is running on the port 22, and I have stopped that SSH service. Is that understood? So when I stop the service, what is happening? It says connection refused. Now to check again if this is true, okay, let me just start the daemon, SSH daemon. And now if I go back to this, okay, it's going to log in. Okay. So I hope you guys learned a lot from this. Okay. Because learning networking is something which you should do hands on. Okay, you should know which IP addresses you're dealing with. Okay, if you're redirecting to some website, you should know how that's done. Okay, trace route 10.211.55.7. Okay, so this is the output for traceroute command. This is as simple as that because why? This is on my exact same computer. It does not take a long route. Okay. So if I have ns lookup bit.ac.in, okay, I have this address. All right. And I do traceroute. So yeah, okay, it's going to display a lot of IPs. Okay, uh, all the IPs which are between your computer and the server computer. Okay, can look into this more. Okay, a very interesting tool is Nmap, and you can also look into Wireshark. Okay, and in Wireshark you can see header files of particular protocols, everything. Okay, so this is a very useful tool. And if you are into cloud, or if you are into any kind of backend web development or backend development in general, you need to have knowledge of computer networking. Okay, without IT fundamentals, you are not going to excel in these areas. Okay, if you're a system administrator, you need networking. If you are a cloud professional, you need networking. If you are dealing anything with something on the internet, you need networking. Okay, at least the basics. Okay, if you face an error saying port 22 is connection refused, you should understand that particular service is not up and running. Okay, so that is how it works. Now, yeah, port 500, port 587, these are all okay. SMTP is stands for Simple Mail Transfer Protocol, and that is for reserved as port 587. Okay, so yeah, I have more sessions which are I have a session entirely on SSH, okay, secure shell, and I will tell you how to log in to another computer without a password. Okay, once you have access to that computer, you can do a lot of things. Okay, so see you in that session, and for now, bye bye. And after the session, please go to AWS, create an account, and try to create a free instance and check what the IP is. Try to run some servers on it like Jenkins or anything. Okay. And if you're doing backend web development or even front end, okay, like instead of just pressing go live on VS Code, okay, instead of just pressing go live on VS Code, you can actually test it. Okay. Uh, instead of you can actually test it. So yeah, thank you so much, guys. Yeah.